Hello, hello, hello. Let's learn today how to find the area of a segment, which is shaded here in pink in the provided drawing on the screen. If you look close at the drawing, you can see that there is a sector, and this sector is made of an isosceles triangle and a segment. So if we find the area of the sector and we find the area of the isosceles triangle, we can subtract them to find the area of the segment. Now, the distance from the center to any point on the circumference is called the radius. And the distance from any point on the circumference to another point on the circumference without passing through the center is called the chord. So as you can see, the sector, there are two radiuses and the arc, and inside the sector there is the chord. Now let's see what numbers are given to me in the question. So we have the radius that is equal to 6 centimeter, and we have the angle that is opposite to the arc, that is opposite to the arc of the sector, is equal to 70 degrees. And as I explained earlier, so the shaded area, which we call it the segment, is equal to the area of the sector minus the area of the isosceles triangle. How do we find the area of a sector? We find the area of a sector by using the formula, which is equal to angle of the sector over 360 pi r squared. And the angle of the sector, as I explained earlier as well, it is opposite to the arc of the sector, which is given to me in the question as 70 degrees. And the radius of this sector, or the radius of the circle, is actually equal to 6. So all what I need to do after writing the general formula of finding the area of a sector is to substitute. So it's going to be 70 over 360 multiplied by pi times 6 to the power of 2. All what you need to do is to insert this in the calculator, and you can leave your answer in terms of pi because you're going to use this number again in the question. Now, we want to find the area of the isosceles triangle. So we start by writing the general formula of finding the area of a triangle, which is equal to half times side 1 times side 2 times sine of the angle between the two sides. So the sides of the isosceles triangle is equal to the radius of the circle. So it's going to be half times 6 times 6 times sine the angle between the two sides, which is equal to 70. Insert this in the calculator and write the answer with all digits, because you're going to use this number again in the question to find the area of the segment, which is shaded again in pink in this question. So that is the basic formula that we're going to use to find the area or the shaded area, which is area of the sector minus area of the isosceles triangle. We found it at first area of the sector, and then we found the area of the isosceles triangle all what we need to do is to subtract the area of the triangle from the area of the sector to find the area of the segment. And then you can put your answer rounded to 3 significant figures, and in this case it's going to be 5.08 centimeter squared. If you look at this question here, all what we changed is the number of the given radius and the number of the angle of the sector, which is opposite to the arc of the sector. So, and we are finding the area of segment, which is shaded in pink again. So the area of the shaded segment is equal to area of the sector, and we subtract from it the area of the isosceles triangle. Area of the sector, we use the general formula of finding the area of the sector, which is the angle of the sector that is right opposite to the arc of the sector over 360 times pi r squared. Substitute the given numbers, so it's going to be 104 over 360 times pi r squared, which is 14 to the power of 2. Insert this in the calculator. Leave your answer in terms of pi because you're going to use this number again in the question. So, once again, we are finding the area of the shaded segment. So, accordingly, we found the area of, and the segment is part of a sector. So, we're going to find the area of the sector at first, and now we're going to find the area of the triangle that is included in the sector as well. So the whole area is the sector, and the partial areas are the isosceles triangle as well as the segment. So the isosceles triangle is found using the formula half times side 1 times side 2 times sine the angle between the two sides. And side 1 is equal to the radius of the sector as well as side 2. So we're going to substitute half times 14 times 14 times the angle or sine of the angle between the two sides. So sine of 104. Insert this in the calculator and write your answer. So again, we're finding the area of the segment or the shaded area in the drawing. So we found the area of the sector, which is the whole shape where the segment is included in this sector. And we found the area of the triangle, which is also within the sector. So to find the shaded area, we're going to subtract the area of the triangle from the area of the sector, and accordingly the area of the segment is going to be equal to 82.8 centimeter squared, and this is rounded to 3 significant figures. I hope that finding the area of a segment is pretty much easy for you to do, and I'm gonna leave this question for you to tackle it on your own. Please, if you struggle with any of the steps, go back and watch this video again. I'm gonna thank you so much for watching the video, for sharing the link of this video, and for subscribing to my YouTube channel.